The massive burden of legacy technical debt costs global enterprises billions in lost agility annually, yet the prospect of modernizing these monolithic systems remains stalled by the extreme complexity of undocumented dependencies, outdated business logic, and the high risk of regression during code migration. Advanced GitHub Copilot integration has moved far beyond simple syntax completion and is now functioning as a strategic asset for systematic legacy modernization, allowing senior engineers to navigate millions of lines of code with a level of insight that previously required months of manual discovery. The first phase of a successful modernization project involves the extraction and documentation of tribal knowledge that has been buried within non-standard code structures for years, and Copilot excels here by synthesizing complex logic into readable architectural summaries. By providing Copilot with specific context through open tabs and targeted queries, developers can generate natural language explanations of obscure legacy functions, helping teams understand why certain architectural decisions were made decades ago without the original authors present. Contextual prompting allows for the identification of hidden side effects in legacy modules where global variables or tight coupling might otherwise cause a system-wide failure when a single component is refactored or moved to a new cloud-native environment. A primary obstacle in legacy systems is the total absence of unit tests, which turns every refactoring attempt into a high-risk gamble that can destabilize production environments and lead to costly downtime for the entire enterprise organization. Advanced Copilot workflows enable engineers to implement a characterization testing strategy where the AI generates comprehensive test suites for existing logic to baseline the current behavior before a single line of the legacy source code is modified for modernization. This automated generation of unit and integration tests ensures that the functional behavior of the legacy application remains entirely consistent throughout the transformation process, providing a safety net that drastically increases developer confidence during structural changes. When transitioning from a monolithic architecture to a microservices-based approach, Copilot assists in identifying natural service boundaries by analyzing the flow of data and dependencies between different modules of the application. The AI can proactively suggest ways to decouple tightly bound components by proposing modern interface abstractions and design patterns like the Strangler Fig pattern, which allows for the incremental replacement of legacy functionality over time. For organizations performing language migrations, such as moving from legacy Java 8 to the latest long-term support versions or migrating from .NET Framework to .NET Core, Copilot accelerates the syntax conversion and library mapping processes significantly. It goes beyond simple translation by recommending equivalent modern libraries and frameworks that provide superior performance, better memory management, and built-in support for contemporary cloud-native deployment patterns like containerization and serverless execution. Security refactoring is a non-negotiable part of modernizing enterprise systems, and Copilot can be used to scan legacy codebases for deprecated cryptographic algorithms, hard-coded credentials, and unsafe data handling procedures that do not meet current compliance standards. By surfacing these vulnerabilities during the development phase, the AI helps engineering teams integrate security best practices directly into the refactored code, moving away from a reactive patch-based security model to a proactive secure-by-design philosophy. Modernizing database interaction layers is another critical area where Copilot delivers value by identifying inefficient SQL patterns like the N+1 query problem, which frequently bottlenecks performance in older object relational mapping implementations. The tool can suggest optimized query structures or implement modern caching strategies that reduce the load on legacy database servers, effectively extending the lifespan of critical backend systems while performance-critical components are being migrated. Mastering context engineering is essential for these advanced use cases, as developers must learn how to feed Copilot relevant metadata about the legacy environment, including existing schema definitions and specific architectural constraints unique to the organization. Without this specific context, the AI may provide generic suggestions that, while syntactically correct, violate internal corporate governance rules or fail to integrate with the bespoke legacy protocols that the application still relies upon. Case studies from early adopters show that using Copilot for initial code analysis and documentation can reduce the discovery phase of a modernization project by 40%, allowing projects that were once considered too expensive to finally proceed. This efficiency gain redirects senior developer focus away from the tedious manual labor of parsing ancient code and towards high-level architectural decision-making, which is where their expertise provides the most significant business value. Using advanced prompt engineering techniques, teams can transform legacy XML configurations into modern Kubernetes YAML manifests or Terraform scripts, effectively automating the infrastructure as code transition alongside the application logic modernization. Copilot also helps bridge the gap to modern DevOps by generating initial CI and CD pipeline configurations for platforms like GitHub Actions or Jenkins based on the existing manual build processes it identifies in the legacy codebase. This AI-assisted automation eases the cultural shift for long-tenured developers who may be experts in the legacy system but are less familiar with modern automated deployment techniques and cloud-native infrastructure management. The role of the developer shifts from a pure coder to a reviewer and orchestrator, where the primary skill becomes validating that the AI-generated refactor meets the strict performance and reliability requirements of a production enterprise environment. Applying AI blindly to legacy systems can introduce subtle logic errors, so it is imperative that teams maintain a robust, human-in-the-loop workflow where every suggestion is scrutinized against the specific business requirements of the system. To speed up the peer review process, developers can use Copilot to generate detailed pull request descriptions that explain the why behind complex refactoring changes, making it easier for reviewers to understand and approve large-scale modifications. Learning and development leaders must recognize that the effective use of Copilot at this level requires structured training that goes beyond basic feature usage and dives deep into architectural transformation and prompt design for large codebases. Providing engineers with the skills to use Copilot for modernization not only accelerates project timelines but also increases employee engagement by removing the most frustrating aspects of working with aging, brittle software systems. Enterprises that fail to adopt these AI-driven modernization techniques risk being left behind by competitors who can iterate faster and maintain lower operational costs by shedding their technical debt through intelligent automation. Successful modernization is an iterative journey where small, AI-assisted improvements build upon each other to eventually transform a rigid monolithic system into a flexible, scalable architecture capable of meeting modern business demands. Standardizing a library of proven prompts for different refactoring tasks across the organization ensures that all modernized code adheres to a consistent quality standard and follows the specific design patterns chosen by the architectural board. When Copilot is treated as a collaborative partner in the architectural process, it can help visualize the end state of the system and provide a roadmap for the step-by-step conversion of legacy modules without disrupting ongoing business operations. It is also vital to integrate these AI tools within existing quality gates, such as static analysis and automated security scanning, to ensure that the speed of AI-driven development does not result in a net decrease in code quality or security posture. As enterprises move toward AI-native development, the ability to rapidly modernize legacy assets will become a core competency for IT departments, transforming the maintenance of old systems from a cost center into a source of competitive advantage. Finally, the governance of these AI tools must include clear policies on data privacy and the use of proprietary code to ensure that the modernization process complies with all industry regulations and internal security policies. To equip your engineering teams with the high-level expertise needed to navigate these complex architectural shifts and maximize the potential of AI-assisted development, explore the advanced GitHub Copilot training from ProgNXT today.